Welcome to day 34 of our school year. Let's get that filled in. So you should have 3 complete rows and then 4 squares for our 34. Let's get down our beginning fraction. We have a total of 180 school days, and we're on day 34. So now we need to find the factors of our numerator, which is 34. 2 factors we always know are 1 and the number itself. So 1 times 34, and using the commutative property of multiplication, we can write 34 times 1. Now we're going to go through all our divisibility rules that we need to, and we're going to go in an orderly fashion. So we're going to go in order so we don't miss any. After 1, we try 2. The rule for 2 is that it ends in an even number. 4 is even, so 2 is a factor. I can get one group of 2 out of 30, that leaves 14, and so I can get 7 groups of 2 out of 14. Our commutative property, 17 times 2. Now we try the rule for 3. The rule for 3 is that we add the digits together, so 3 plus 4 equals 7. Is 7 a multiple of 3? No, so 3 is not a factor. We try 4. One thing to look at is if the second factor with 2 is even or not. It is odd, so 4 will not be a factor since this one's not even. And it's 4 times 8 is 32, and then 4 times 9 is 36. 34 is not in that list. We try 5. The rule for 5 is that it ends in a 0 or 5. It ends in a 4, so 5 is not a factor. We try 6. The rule for 6 is that both 2 and 3 are factors. 2 is, 3 is not, so 6 is not a factor. We try 7. We just list the factors of 7. I'm sorry, the multiples of 7. 7, 14, 21, 28, 35. 34 is not in that list, so 7 is not a factor. At this point, I might want to check to see if 17 is prime, because if it's prime, then we're done. Let's see. Yes, 17 circled, so 17 is prime. That means we're done. And we can list our factors from least to greatest. 1, 2, 17, 34. We have 4 factors. That's more than 2 factors, so that means this number is composite. Now we need to figure out which of these factors is our greatest common one. So now let's start with our greatest factor to see if it's common to both, if it works for both. If it doesn't, then we'll go into the next one. So it doesn't matter if your groups look like mine. They just have to have 34, and you don't mix your shaded in with your unshaded. So here I have 6 plus 20 is 26 plus 8 is 34. 2 plus 30 plus 2 more is 34. 8 plus 20 is 28. Plus 6 is 34. And 4 plus 30 is 34. And I have 10 left over, so that means 34 is not our greatest common factor. So we try our next one, which is 17. Okay, so 10 plus 7 is 17. 3 plus 10 plus 4 is 17. So again, your groups don't have to look like mine. Just make sure there's 17 in each group, and your shaded is separated from your unshaded. So I have 6 plus 10 plus 1. Here I have 9 plus 8. 2 plus 10 plus 5. plus 10 plus 2. 8 plus 9. Plus 10 plus 6. 4 plus 10 plus 3. And 7 plus 10. And again, I'm left with 10. So 17 is not our greatest common factor. Okay, so let's try groups of 2. Groups of 2. Your groups do not have to look like mine, but you do have to have 2 in each group, and you need to keep your shaded separated from your unshaded. All right, 2 worked. We found one. So that means 2 is our greatest common factor. Okay, now we need to count up our total amounts of groups of 2. Since each of my rows has 1, 2, 3, 4, 5 groups of 2 in it, I can count by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. There are a total of 90 groups of 2. And I have 5, 10, 15, 16, 17 of them shaded in. So I've used my model for my division. Now I'm going to use my algorithm. I'm going to divide both of them by my greatest common factor, because I always have to divide by the same amount. It has to work for both. It has to be a common factor. And I didn't make different groups in my shaded than in my unshaded. They're the same amount of groups every time. So let's go ahead and do our long division. 180 divided by 2. 34 divided by 2. Let's see, 2 times 50 is 100. Numbers the same, zeros the game, more on top, no need to stop. And then here, let's try 20. 20 times 2 is 40. Numbers the same, zeros the game, more on top, no need to stop. 20 times 2 is 40. Numbers the same, zeros the game. Add up these partial quotients. 0 plus 0 plus 0. 5, 6, 7, 8, 9. I get 90. Okay, over here, 10 times 2 is 20. More on top, no need to stop. More on top, no need to stop. 7 times 2 is 14. Numbers the same, zeros the game. Add up our partial quotients. 10 plus 7 is 17. Now we need to check our answer. To check, we do our divisor times our quotient plus our remainder. Divisor times quotient plus remainder. Since our remainder for both is 0, and the identity property of addition says when you add 0, it stays the same, we don't need to actually add it because it's just going to stay the same. 2 times 0 is 0. 2 times 9 tenths is 18 tenths, or 180. 2 times 7 is 14. 2 times 10 is 20, plus one more 10 is 30. Now I need to see 34. Does that match our dividend up here? Yes. 180. Does that match our dividend up here? Yes. So our numerator is definitely 17. Our denominator is definitely 90. So now let's go ahead and fill in our data collection page. Still in trimester 1, week 8. Today is 9/25/19. And our fraction for today is 17/90. Okay, let's go ahead and get out our number line. We did groups of 2. So 14/90, that is equivalent to 7/45, the simplest form. 15/90, that is equivalent to 10/60, and 1/6 is the simplest form. 16/90 is equivalent to 8/45, the simplest form, and then today 17/90, that is our simplest form. That is our equivalent fraction in lowest terms. No lines below it, only above it. Okay, let's go ahead and put your number line away, erase your worksheet, and thank you for joining me.